Welcome to my session called Continuous Delivery, Anti-Patterns. I'm speaking about anti-patterns, first of all, because some people say I like complaining. And, well, second thing, continuous delivery is it's a nice buzzword, quite popular recently. There are so many things you can do in your organization to make it work, but it's a very organization-dependent topic, so I find it easier to speak about the things that did go wrong in the organizations I have worked with. Some things about me. My name is Andrzej. I happen to work at eBay. I have a Twitter, I have an email, I have a blog which is not very active. Whatever I say is not eBay's opinion, that's just a normal disclaimer, so that nobody from legal from my company would be angry. If you could have heard about Geekon, have you? Anybody? Well, that's the conference I organize. I also run the Polish Java user group, software craftsmanship in Kraków, run Kraków Hadoop user group, and, well, worked at the companies with logos down there. There will be a Geekon next year in May in Kraków again. Just saying. Sometimes people, sum me up to the level that I hate computers because of how much I complain about how bad they are or how bad certain programs are. And, well, if you have any questions and if you need answers right away, well, if they fit, well, take them. If they don't fit, ask the question, well, raise the hand whenever you feel like it. Probably you will get a mic. In case you don't get a mic, I will try to repeat the question and answer it. And I've heard that there is a Twitter hashtag. Who has Twitter in here? Raise your hands up. Hi. So it's similar to where I come from. Not many people use Twitter. If you have a Twitter account, try to tweet. I'll be really happy to get some feedback. So, if you're sleepy, because it's after lunch, release more often. Don't listen to anybody saying that it's not possible. It is possible. It might be difficult. The very big thing about software for me is that the most problems, unfortunately, happen to be non-technical. It's about people, how you work with them, how people design certain processes, certain procedures, certain things around the software that make doing this software quite difficult. So in the beginning, there is a quote. Anybody recognizes the quote? Yes, it's from Agile Manifesto. I would give you a mug, but I don't have any to give, so, well. A mug, a prize, because he answered the question, but I don't think that's, okay. Yeah, Agile Manifesto talks about continuous delivery. It's an awesome thing that it does, but the tricky bit is that it doesn't tell you how to do it. And the reason why it doesn't is because there is no silver bullet. There is no just do TDD and your software will work and your delivery will work. It just so happens that delivery is a very organization-specific problem. Doing software delivery in Oracle in a SaaS model will be quite different than doing it in an on-premise and quite different in for example, a gaming company that has to ship a physical DVD to the gamers. If you're doing a mobile application, your delivery model will be different to that as well. In a bank, even more different. So it's really a very organization and very business-specific thing. I cannot give you a golden rule book to follow, but there are some things that I know that don't work, or some symptoms that if you recognize them in your organization, you might try to take a step back and see if what you're trying to achieve is actually happening the right way. If you have some problems, the first thing to do is actually recognize them. If you know them, do a list, prioritize them, and try to tackle only the first one. The reason being, similarly to performance problems, if you actually kill the first one, the rest of the problems might either disappear, become less important, or well, something else might happen. They might reshuffle. So after you kill one, you redo the list and then fix it. And now imagine, in a situation that a long time ago in a galaxy far, far away, there is a system that has users, runs somewhere. The specifics are not really that important. There are developers who develop like crazy, like here. They push their code, and suddenly, well, site breaks. Well, what's even worse, that the site breaks for 2 days. Nobody's happy. Because it's during hot season, think Black Monday, think whatever hot season means for your business. Decision is obvious. Oh, we roll back. And the question becomes, well, to where should we roll back to? And somebody else asked the question, okay, where were we? Where do we want to roll back from? How do we even track this? So the problem is, quite frequently, that companies have no idea what they have in production. They do not know the versions, they do not know Git hashes, they actually strip it out. It's a bad thing if that happens. One symptom might be that somebody connected his Eclipse workspace to the production code and actually tries to develop software or debug software live. Of course, yes, it gives you the adrenaline rush that you wish, but in terms of scaling and traceability and auditing, that's a bad thing. And if you think that's a really far-fetched example, I have seen it in 2013, this year, in a big organization. But I will not tell you which one. That's another thing that might happen. Somebody will force push to a prod branch, to a prod tag or something. That's slightly better, but not perfect. Ideally, you would like your software to have versions. Why versions? Because 1.0.3 is much better to me as a human than an MD5 or a hash. It's just easier to read. It also has meaning. You probably do it already. If your versions also are easily sortable using pipe sort, that's even better. That's quite straightforward to operate. Unfortunately, some companies don't do that. I know a company that calls their releases. First they do a, let's call it 3.5. Then they do a 3.5a, like alpha, but it's not an alpha, it's a subsequent release to 3.5. Then they do a 3.5b, and for example, they might do a 3.5b R11. And that gets totally confusing to everybody. Try to do it semantically. Try to also make your software have a -- version flag or a page or a URL that actually you can access and see which version it actually runs. It will make your lives easier. It makes doing any dashboards that track versions easier. And speaking of dashboards, do know what version you have in which environment. Have a tool for that. In my history, it meant quite a few Grails applications that actually tracked it, doing a big grid listing. Which software, which box, which version, and which environment. That's quite straightforward, but having such a visibility is very useful. If you're doing an application that is actually in a scripting language, say Ruby, say JavaScript, say, well, something else, you could do a trick that's called doing multiple repositories, or you can also do it with any other kind of application. The idea is to take a repo, the one that developers work in, and when they do a release, the release process can actually make a commit or a push into a production repo. This way, whatever developers do in their repo, even if they break it, they don't break the production repo. This separation gives you security. Of course, it gives you 2 repos instead of 1, but right now, SVN repositories, Git repositories are quite cheap. It's not ClearCase is everywhere anymore, but if you have ClearCase, then having a separate repo might come at a cost. If you'd like a tool that does release tracking and releasing for you, or allows to automate a few things, I recommend Glue. It's an open source bit. Looks more or less like that. It's quite easy to configure. You can give it a try. It might work, it might not work for you. I used it in a few places. It did work. I also, in a few other places, didn't use it at all because doing scripting was just easier. But coming back to our system story, everything broke down. We managed to fix it, but still there was a 2-day delay in the hot season, so bazillions of dollars lost. What does the business think? Well, the business makes an obvious conclusion. Releases equals risk. So let's avoid the risk. That's quite easy. Let's not do releases. And then you get into a funny situation where you get stagnation. You get things like quiet periods. You get release trains. And the word trains means that there is a train with a release that you can catch every second other week. So, because of course doing a release once every 2 weeks doesn't really work, because then you get hot patches, then there is a special word for the last wagon on the train, which is called caboose, and then some people can commit or push into that caboose, which of course circumvents the whole process, but that's what happens when you get infrequent releases. There is a company, a big travel industry software provider that did a release of their software into UAT, so user acceptance testing, to a customer of theirs, and the software, like wine, waited for a year. And unfortunately, unlike wine, the software didn't get better. When it finally got launched, it didn't work. Surprise. Well, it was a surprise to some people because they thought, well, it was being tested. No, the zip package was just lying there in the environment on any drive. Nothing really was happening, and you know that bugs get fixed only on master or head or whatever your development branch is called. RC, beta, gold, that's usually a sign of a problem. I'm saying usually because, as I mentioned, if you actually have to ship physical disks, or if you have to ship devices, you have to make sure that they actually work. Because if your customer puts a well, if I put a CD or a DVD with a game into my computer and it doesn't work, I'm quite angry. I'm going to give it a few tries. I'm going to call support. In the worst case, they will have to re-release the CDs. It will be a marketing failure. It will be a huge cost for the company. In such a case, doing an RC is probably okay. Doing a beta is also okay. If you're doing a software on-premise with a, well, problematic customer, then it might be acceptable. If you own the software, on the other hand, don't do that. Try to do as close to continuous delivery and continuous deploys as possible. Of course, while maintaining quality. So the problem that we have is fear of releasing. What do you do to get business around it? Well, you involve them. Some people call that, especially in corporations, you manage your stakeholders. How do you do that? Well, you can just ask your manager, ask somebody, okay, I do this very tiny little commit, I changed a single line. How long does it take for it to reach production? How long should it take? If the answer is 2 weeks, something is not quite right. A big feature might take 2 weeks because it's a big feature, like a big car, it's heavy. But a tiny little bit, it should be, well, just push it. Just commit it, deploy it, it's a good selling point to talk about such a small change. Usually, business falls into the trap and they want to help, not circumvent, but design a better process. Also, environments, which is a funny bit. Of course, some of the, do you care about your environments actually? Because I know some Java developers just release a WAR file. They don't have to care or cater for whatever gets later. Yes, no, yes, yes, a little bit. So in terms of Java, that's usually a smaller problem because we have, well, our life is more beautiful, but slightly more complex. Usually, you get a pipeline, which means you have a Jenkins build that does unit tests, acceptance tests, some other tests, you have it deployed somewhere. The problem with such a pipeline is, well, usually it's slow. What can you do? Well, the answer is obvious, you just parallelize. And when you parallelize, you have to make a decision about which part to parallelize. The answer is, well, quite simple. Or it would seem quite simple, but the proper way to approach the problem is to make a list of all the components, see how much time you lose where, see where you can win the most with the smallest cost, and then try to optimize for that. Then redo the list. What you win, you will get a more decoupled design, because if your, for example, automated tests relied on a single database instance and you script it enough so that you can run multiple instances of that, you win. If you decouple your architecture, remove statics from your code so that multiple tests can be run at the same time, you win. If you find some concurrency problems, well, you win again. There is no golden rule about what to decouple and what will happen, but it's usually a helpful thing. If you can run your software in parallel in the same machine, that's a great thing. Also, when you have a pipeline, the problem that is closely connected is called recompiling. So you run your unit test, you do a Maven clean test, then you do a Maven release, and then release perform, and then what happens is you have actually compiled your software 3 times. For Java, usually that's not a big deal. If you happen to have worked with any C++ applications, you know how much compilation can take. 6 hours, anyone? More? I've seen a bit of software that was, the whole build took a day. And there are bigger things in the world that I have not yet seen. So why is recompiling bad? Well, that could be one of the answers. Of course, if you're on the developer side and you actually get to play with swords or go cycling or, I don't know, lie in a hammock, then that's probably okay. But it doesn't really make sense to lose so much time. But the biggest thing is if you do separate production builds, separate staging builds, separate developer builds, is you cannot really replicate the reality of the production code. Because if the production code is something completely different from what you get to work with, it gets harder. Not in terms of Java, in most of cases, but if you have C++ dev sets, or if you have a Ruby application that actually behaves differently depending on how it was put together, it will be tricky. So replication of any problems, tracing back any problems becomes really difficult. What you can do, what you should do, is use a binary repository. If you like Baruch, use Artifactory. If you prefer Nexus, use Nexus. If you have anything else, you can use S3. You can use absolutely anything that you do. You should try to not waste time doing compilations. Also, in a C++-like environments, the magic set of compiler flags becomes a treasure. Maintaining that becomes problematic, and soon you might end up in a world in which only a single machine can do the proper compilation thing, which is not that great. It's actually a very bad thing, because when that machine breaks, you lose. You have to, well, rebuild it. You have to find out what the set of compilation flags was. It gets tricky. So let's move on. A problem. I call it separate teams. I used to call it the release team, but since I don't think that having a team that actually does the releases and is physically responsible for doing the releases is a bad thing on its own, it is bad when the developers and ops and the release team don't talk together, because then teams start to work in void. They have their own versions of reality. So release guys might ask for a special set of flags for developers. Developers might produce different sets of flags for development purposes, and it doesn't really work. Also, how can you tell whether that's happening? If there is a release team that deals with danger, don't disturb them because they are releasing. You have stories like, they make the processes more and more manual because they care about their job security. You get approaches which get close to us versus them. Don't touch me, I'm doing the important stuff, so I can slack for 2 days, but I will say that I'm busy because I'm releasing, or I will just do ct find merge something, or run some script that runs for 2 days and I will have nothing to do but watching YouTube videos. That happens. And that's a very unfair situation, because usually in companies, people see what everybody else is doing in their close proximity. So if you see that those 2 guys that actually just have turned their desks so their monitors are not visible are actually slacking, you'll be angry. People will leave. They will like this position, of course, because it's very comfortable for them, but it's a bad sign because it is reflected on how the software works. What you can do with the, well, we are dealing with danger and communication problems. You can, what you also get is you get release processes that become more and more curious. So before you release, turn left twice, then walk backwards 10 steps and use a special SSH machine. You also might get a very only single developer or only one single guy in the office that can do a release because only he has the proper set of production access keys or whatever. It really depends, but it might get funny. So the track factor comes into play. If the guy breaks his leg while skiing or while cycling or, well, just happens to have a good party, you will not be able to release. So if your company then makes money out of the software and you're not able to release and there is a bug, then one guy will be able to prevent the company from making money. That's not a good situation. Usually not immediately, but when business realizes that, they will try to push, of course, more curious processes on top of that. And the good thing is to, well, not let this happen. Anybody familiar with Parkinson's law? This, well, from my experience, unfortunately, it happens. So what happens in reality is that developers get magic access to the production boxes, start pushing jars, start emailing jars to customers. Of course, any developer, where they're sold, will at least sign the jar if it's traveling through email to actually make sure that the jar that the customer received is exactly the one that they should have. Maybe they will even be kind enough to do a tag in the SCM. But if somebody then from the outside of that small bit of reality to audit what is actually running, they will be surprised, perplexed at least. You get unofficial releases, which also mean that some of the developers stop doing development because they start doing release, and there is a release team that should be doing releases, but they are slacking, so everybody's unhappy and people start to quit. And it's a good situation on the job market that you don't have to look for a job for long, but still, it's mentally wrong, and people feel that it's wrong inside. Another thing is you can get physical bunkers. Maybe not like that, but the release team or the separate teams might get desks that prevent any visibility, or there might be a physical barrier between them. They might want to occupy a conference room, so basically erect a physical protection, preventing anybody else putting their nose into whatever they're doing. How do you deal with it? It's a people problem. So you try to encourage interactions. You have to break the barriers, you have to integrate the teams, you have to actually teach the guys to talk together. And you have to do it repeatedly. One-off paintball, one-off go-karts evening will not do it. A drink cup will help. What really works is computer games. We had this problem in one of the companies I worked for. Developers sat here, operations / release / environment guys sat there. Nobody would cross the line, nobody. What happened was we started playing Wolfenstein, enemy territory, because it's a very heavily cooperative game. Of course, if somebody shoots well, he will be high in the rankings, but if the team tries to work together, they can achieve the objective, and a single perfect shooter will not help. What happened is we mixed teams, and people, when they at first screamed at each other, how do you play, you, well, put in your favorites kitchen Latin here, they realized they can actually complain to, well, ops to developers, developers to ops. What also happened, there was a manager who really wanted to be the highest position in the office, and when he was playing, he was like everybody else. He didn't have any superpowers, people didn't have to follow his rule, because, well, it started to self-organize, only in the game at first, but it really helped. Of course, there is some problem with launching games in an office. especially if you work for a corporation that has tight security, but, well, right now everybody has laptops or you can get consoles, you can go around it. But playing a game for half an hour a day for a few weeks is something that actually helps tremendously. Another problem that you can get is manual infrastructure. Manual infrastructure is a problem because if you need another admin, the process is very easy. You find a male, you find a female, you hope it works with them. You wait 25 years, also trying to make the kid into a geek and then into a technology and then into this particular technology you need. Bang, you have an admin, or you have a developer or somebody who can do your infrastructure. Of course, the world stands still for 25 years because why would it not? Reality, of course, doesn't permit it. So infrastructure needs to be maintained like code. You probably all know that very well. Some people use infrastructure automation tools like Chef, like Puppet. They think they are very safe with that. But there is a funny bit. Doing infrastructure automation needs testing. If you treat infrastructure like code, you have to test it. If you bring down all of your 500 or 5,000 machines in Amazon or any other cloud, you're quite unhappy. It turns out, if you're doing Chef, if you're doing Puppet, you can do TDD to some sort or sort of, because it's not fully TDD, because you will have to do the integration tests again, because you have to see which packages actually happen if the system comes up, if it works as expected. But you can do some sort of TDD, and something that helps, again, with interactions between the admin or ops part and the developer part is doing TDD together. Admins usually, I'm stereotyping here because it's useful, don't have that much experience doing software testing. Developers have pretty, extensive experience using JUnit, whatever other tool you use for doing TDD. You can sit together, you can pair on that, and then break the barriers and to see that each one of you is a very valuable person with a different specialty. But if you work together, things get awesome. Also, you can get static analysis. For Chefs, the tool is called Food Critic. For Puppet, I have no idea. Probably there is something. For other tools, maybe. Should you use Puppet? Should you use Chef? Should you use something else? Just talk to your ops, ask what they do, and then try to automate whatever your software uses, and then use the same tool that those guys use, because they will be able to help you with problems, and it will fit your infrastructure naturally. Another problem is, I said that you have to do the integration tests. So doing env builds will be slow, because of how soon, how apt-get works, or whatever else you use, because of software installation times, because of how much data has to be put through an internet connection. You know the answer already. You can parallelize things. You can actually, use snapshots. A fully patched system from a day is a good starting point. You don't have to patch all the systems from the base Debian or base Ubuntu or base what have you that you have. You probably also don't have a very bare image being used in your environment, but try to parallelize, try to put the packages as one step of the build, then put the configuration values and then test it all together as a separate part of the build. And then we come to the next problem with environments as a whole. Environments, builds, and, everything. The problem is called the internet. Do you know what this machine is? Obviously you do. Do you know what it really likes eating? And it's not dirt, it's not ground. It actually loves the internet cables. At least wherever I happen to be, once upon a time, every few months, there is a story that there has been an excavation site, and suddenly, after an excavation site, there is an internet outage and a power outage, because some cables were supposed to be here, but they actually were more over there. Maps don't fit reality. So you will get your internet connection down. Do you need your internet to build? Well, usually you do. Because why not? Because it's always there. You know these sites, at least you probably know Maven.org. You know Ruby gems, if you've done any Ruby, if you've done any Perl, you know cpan. There are other pages like that. They do go down. It's very easy to make Maven.org go down for you. Imagine some DNS changes that you didn't get, or some very eager admin configuring firewall, and it's cut off, and you don't have access. Another thing is, because it's an external site, you don't have any control over what's happening. You can only trust them that they will not do bad things to the packages that are over there. You of course also have to download them each time you use it. So the solution is at least try to make your build run without the internet. I'm not saying that you have to, because it might be a very difficult thing to do. It might require networking tricks. It is quite a big job, but if you actually try to do that, what you get is you learn how your build works. You see what packages, what components come from where, and then you might learn that a framework that you use uses a third-party single GitHub commit library, which is not that awesome. But the reality is we found a thing like that in a gaming company. They learned that somebody else uses, I think it was a templating engine that actually has a single commit on GitHub. Sounds very proper. Try to do it for your application and environment. In case internet goes down, you'll be able to build. But that's unlikely. The thing is, if you have all the binaries under your control, you know that somebody else cannot change them. Especially if you're doing any serious environments, you don't want somebody else to be able to poison a package, break whatever is in GitHub, break whatever is in Maven.org or somewhere else. It is possible, because software has security problems all the time. You will also save yourselves a lot of time. If you have a very slow internet connection, which is still very much of a problem in so many places. And I happen to work in London, and we have problem with internet connectivity to certain places. You will save yourselves a lot of time and nerves if you have decent proxy, decent package repositories locally available to you. You will also make your builds much faster. And you know the tools for that. In terms of proxy, talk to your network guys. Another problem is that people sometimes don't upgrade runtimes. I don't want to know if you still have to work with JDK 4 or 5, but a few days ago I met somebody who was actually quite happy because their company just upgraded to JDK 1.4. And it's 2013, and he wasn't drunk, and I wasn't drunk. Yeah, a picture. Did Rails have a major security flaw today? Well, today no, because it's an old picture, but they have problems. Java, just a few updates. The ones without the red rectangle are without any security updates. 3 of them up till update 21. So your runtime gets updated, your runtime gets patched. You also get free performance boosts with the JVM getting faster and faster. It should be updated. It gets tricky if you have desktop applications. You know Firefox, you know that Firefox used to be very bad about it, because I want to access the internet, so you click the icon and Firefox is downloading the update, it's installing, then it restarts itself. It's irritating for the users. Don't make your software like Firefox used to be. Make your software more like Chrome if you can, because some of the business reality might force otherwise, but don't prevent your users from using your software, because they will hate it. If they have no choice, well, they will have no choice, but if they have a choice, they will just skip it. Mobile applications, WebView is awesome. Frequent releases make your user curious. If you release too frequently, you will notice a down trend in the number of people using your applications, because people don't like their paid for 3G bandwidth to be wasted on you not being able to push out a proper version, unfortunately. That I have seen that happen with an application because we did a few hot updates. Also, if anybody quite well looks at releases being called security releases and that they happen on a weekly basis, it gives you a very, very bad impression that the software developers don't have no clue about how they are doing and what they're doing because they cannot fix the bugs or they maybe introduce others while fixing. We noticed that with the JVM. It also happened to Rails. It's a bad thing. If you're using if you have a backend that just exposes services, yes, you can change it. Nobody will mind as long as it's okay. What you can do is ask users if they want new features, or you can ask them if they want better performance. You don't have to do anything. You don't have to put thread sleeps in. Just ask them for better performance. It has performance enhancements, and people will click yes. They will gladly wait to download or to install or whatever. It's a trick to the psyche, but it works. Forcing people to update doesn't work because they just get irritated and they just, well, stand up, go smoke, go cycling, go for a walk, start complaining. Another problem that we have is deployment failures. So what happens when you run a deployment and it fails? Well, what you can do at first to prevent having problems with deployments is have a visible, well, an information radiator. So have a counter, so many days till last failed deploy, so many days with a green build, so many days with well, things going all okay. And then when people will notice that everyone else is actually doing a good job, they will be afraid to do a bad one. That works. That's a small trick. But, well, you have to track your deployments and you have to also have a failed deployment procedure. What it means is not that you need to have a Word document. You need to know what to do in case the latest release doesn't really work. Should you do a downtime? Should you do a rollback? Or should you wake everybody and fix the problem right away because there is only a single live version of the application? You should know it. Somebody has to know it. That's why if you have an actual release team, they will probably know the answers to those questions. And if you don't like it, you can change the process, but first you have to have it. Also, try to test your rollback. How can you do it? If you have multiple data centers, you can do a blue-green deploy or deploy one version to one data center, then another version to another data center. That also gives you some fallback mechanism between data centers, but you have to test it. And also you have to test your backups. I know of an organization that was thinking that they are doing MySQL backups, but they were always very small backups. The reality was that it was an empty zip file. It contained no actual contents of the database at all. They were very lucky because they managed to recover the actual disk drives that powered their database, so they didn't lose their data. But you have to try to use your backups and restore them. If you just store your data without storing your schema, you know that you'll have problems. Which leads us to a problem called state. State in applications usually is a source of all kinds of problems. We all know that. We know concurrency is hard. If you have long-running processes, long-running transactions, I would recommend looking at a paper about sagas. It's an old paper from the 1970s. It's about how to deal with them. It's useful. It doesn't, of course, give you all the solutions, all the current state of knowledge, but it's a very good paper. I highly recommend seeing that. If you, on the other hand, would like to do something to databases, then I will not cover them here. There is a talk called Patterns of SaaS Refactoring Databases in this room right after me. And then there is a talk about TDD for database-related code, again, in this room. Environments. Coming back to them. Love partial failures, or in other words, if you're running a big e-commerce site and one of your payment providers goes down, you shouldn't display a 404 or a 500 into user's face, because that's just bad practice. Users don't care. Store the transaction, maybe tell them that it's not possible, or encourage them to come back later. What you can do is actually try to run the application on your desktop and run a other components also on your desktop and do Ctrl-Z to one of the processes. If the main application survives that, you're quite happy. If it doesn't, well, you know what to fix. Of course, probabilities and costs come into play because some things should not go down because they have SLAs, but the reality is they all go down. It's just a matter of time. Try to build in switches that disable parts of functionality. You can disable a few buttons. You can remove a button from the UI. You can make it gray for the moment without breaking the applications. Users will be happy because it's okay. If you look at Google, Gmail is in beta or was in beta for such a long time. Users are quite forgiving and if some features are not available at a certain time, because if that's really a bad thing, they might write you a bug report. But if that's not really crucial, they might just, well, forget about it or write it on a to-do list. Try to make your application aware of the external systems that it depends on and be able to disable those dependencies in runtime. It's a very useful thing. You can make your application environment aware. So if your application can tell if it's running in production with a certain set of flags and you can switch it with a switch without rebooting it, it's good. It's a good thing because then that means that you can change configuration on the fly, add a new load balancer, press a button and it will know. You can add a new database and the application will become aware of it. But then let's go to your own development environment. If you get a new hire, you have a new guy that actually starts working today. How long will it take the guy to be able to do the first commit? Months. Okay, I don't have experience with banking, so that might be a complex environment. Yeah. Yeah, so it's a very complex procedure, but usually you also have to set up the software on your machine in a certain way. You also have to, well, find out about the magic flags that you have to have, about the magic property files, and then you have to change the magic property files to some magic values, usually by copying another guy's environment. What you can do is you can automate things. If you can make a VM that runs your environment from scratch to fully, well, at least to the compile stage in 5 minutes or an hour, it's a huge win. You can use the tools mentioned, Chef, Puppet. Right now, Ansible becomes a very popular thing. You can use Docker, you can use Vagrant, you can mix them as well. Pick any, try to automate some things, and, well, this is what Chef looks like. It's a very simple DSL. It's not that hard to learn it. You can automate a lot of the tedious part about managing a developer's workstation using Chef. You can also use other things in probably a week or maybe 2 weeks. We did that in eBay, and for us to add a new machine to any of the stages, to any of the applications in the project I work in, it's less than an hour. And it's less than an hour because of the auto-discovery that certain applications need to do of the new machine. We have everything in Chef, and it's a very pleasant situation to be. It took us, as I say, 2 weeks. People found Chef to be very easy to read and easy to write because other guys in my team didn't know it before. Highly recommended, especially if you use Vagrant to do TDD-like. And that brings us to, well, the end. So you can release, well, the Kraken, if you have seen the movie. Any questions? If there are no questions, well, find me somewhere else. I'll be happy to talk. If not talk, then we can at least have a beer. Of course. So the question is, how do you use Mercurial or Git for continuous delivery? You're asking about branches. We try to follow stable master and always do everything from master. We try not to have branches. That's one of the approaches. There is there are different models for Git. It really depends on what you like. If your developers are happy with doing a stable master and are okay with not breaking things, try stable master. That's also my personal favorite. You can also do a very simple production branch. That's what a team right next to us uses. Each commit, they run unit tests. If the unit tests pass, they put the code through all sorts of automated integration tests. If that's okay, they tag it, and that's a releasable version. You can use Git flow. There is a nice blog post about it, explaining the process, well, lengthy. You can also have something custom. You can have multiple repositories. With Git, it's very easy to do branches. That's why I try to encourage people to have very short-lived branches, because they can, well, just do whatever they need on the branch and then do a squashed commit to master, so that you don't lose the history of how work happened, but you also don't lose the stability. Does it answer your question? Awesome. 1, 2, 3. Nothing. Thank you very much, guys.